All right. Welcome to lesson 9. I'm going to try something a little bit different today. I'll give you the normal slideshow and you can pause along the way as you work on these problems at home. So first off, lesson 9, this is the first lesson leading us to an understanding of scientific notation and why it's so useful. The learning target, given a very large or small number, I can write an expression equal to it using a power of 10. So scientific notation is all about powers of 10. The warm-up question in your package, you can see it. Match each of the expressions with the corresponding value and word. And then for each of the numbers, think of something in the world that's described by that number. So take a moment, you can pause the video, and I'll give you the answer in 3, 2, 1. So here, for example, this expression, 10 to the negative third, matches up with 1 over 1,000 because 10 to the negative third doesn't mean 10 to the third power, but negative, it means 1 over 10 to the third power. And in this case, that's 1 over 1,000. The prefix would be milli, as in millimeter. That means there's 1,000 millimeters in a meter because each millimeter is 1,000th of a meter. Another example, 10 to the 6th power is the same as a million because 10 times 10 times 10 times 10 times 10 times 10. You can see the 6 zeros because we multiplied 6 tens is a million, and so on. An example of a million would be there's 10 million people in New York City approximately. There's 1.1 million children, students. Example of a billion, there's a billion people in India. Example of a trillion, 10 of you have a trillion brain cells between you all. It's also 1/20th of the GDP, the gross domestic product of the United States, the value of money in dollars. Here's a chart, a more complete chart of all these different prefixes and how they change all the way up from a septillion down to a septillionth. And you can see, for example, these are all meters, but they apply, for example, to bytes. So you could have 1 byte, which is 8 bits of information in computer speak. A kilobyte is 1,000 bytes. A megabyte is 1,000,000 bytes. A gigabyte is 1,000,000,000 bytes. A terabyte is 1,000,000,000,000 bytes. So powers of 10 are just so useful. Most countries use this standard metric system to measure things because it's so easy to work with powers of 10. All right, so next up, just a few examples to get you thinking about how, if you change the unit, what does a diagram look like given these different units? So for example, in this diagram, you have a 100 block, 2 10 blocks, and a single block. And if we say that each of the small squares represents a tree, what would the whole diagram represent? You can take a moment, think about it, and I'll give you the answer in 3, 2, 1. Well, if this is 1 tree, then this would be 20 trees, and this would be 100 trees. And so all in all, we would have 121 trees. Now let's imagine that each square, small square, represents 10 books. What would the whole diagram represent? Think about it, and I'll give you the answer in 3, 2, 1. Well, here, this would be 10 times 100 because it's 10 copies of 100 books, so 1,000 books. This is 10 times 20, or 200 books, and this is 10 books. So overall, you'd have 1,210 books. Now imagine each small square represents 1,000,000 stars. What would the whole diagram represent? Here's the answer in 3, 2, 1. Well, if this is 1,000,000 stars, then this is 20 million stars, and this would be 100 million stars. So altogether, this would be 121 million stars. Last example, if each small square now represents 1/10 of a second, what would the whole diagram represent? How many seconds in total? Pause the video, think about it. I'll give you the answer in 3, 2, 1. So the small square is 1/10 of a second. This is 20/10ths of a second, or 2 seconds. And this is 100/10ths of a second, or 10 seconds. So altogether, this would be 12.1 seconds. So this is the next problem in your packet. You can also see it online. And it's asking you to match each of the expressions, the first, second, third, and fourth, with one or more of these 3 diagrams. So here you can see 200 blocks and 4 singles. This one shows 200 blocks and 4 tens. And this one shows 210 blocks and 4 singles. So keep in mind, there might be more than one match for each diagram. Pause the video, take a moment to think about which one you think could match up, and what's the value of a single small square in order to make, for example, this first expression match whichever diagrams you think. So this first one could be B or C. This would be 2/10ths plus 4/100ths, and that could be B if each of these represented 100th, or it could be C if each of these represented 1,000th. The second one could only be A, and that would be true that you'd have 2/10ths and 4/1000ths if each of the single blocks was 1,000th. The third one, again, can only be A. You might notice that here the power of 10 is different by 2, whereas here it was different by 1, and here it's different by 2 again, so that's why it's A and not B or C. Here, in order for this to be 4 times 10, or 40, plus 2 times 1,000, so 1,040, each of these would have to represent 10 for each of the little blocks. And then lastly, it could be B or C. B if each of these single squares represents 100, or C if each of the single squares represents 10. So now take a look at here. What expression could describe the base 10 diagram if each of the small squares represented 10 to the negative 4th power? That would be 1 over 10 to the 4th, or 1 over 10,000. So each of these small squares is 1/10,000th. Take a moment and think about it. When you're ready, unpause and check your work. So here you have 4 copies of 10,000ths. So this would be 4/10,000ths. Then you have 50 copies of it. So this would be 50/10,000ths, which is the same thing as 5,000ths. And then here you have 200 copies of 10,000th, which is the same as 200ths. And so overall, this diagram would represent 254 10,000ths, or 0.0254. The next activity in your packets would be normally to get some cards with information to share with a partner. And then you would use this to talk to your partner and ask them to write down these words on their own. So, for example, you would tell them light waves travel through space at a speed of 300 million meters per second. Wow, light is so fast. And how would your partner write that saying down with just numbers instead of words? So take a moment, jot it down on your page for each of these 8 different examples. using standard base 10 notation. And here is some example of what you could have written. You might have written the distance to the sun is 100,000 million billion, 150 billion meters, or you could write it as 150 times a billion, or 10 to the 9th meters. And as our first example said, the speed of light is 300 million meters per second. So you could write it out 300 million, or maybe you wrote it as 300 times a million, or 300 times 10 to the 6th power. Notice that when we start talking about really small numbers, the powers of 10 become negative. And that's because we're talking about 1 over 10 to that power. So 1 over 10 to the 13th is a really small number. And so here the wavelength of a gamma ray is 48 times 10 to the negative 13th, which is less than a trillionth. It's 4.8 trillionths of a meter. It's really tiny. Or even smaller still, the mass of a proton. So when you think about some of these tiny, tiny things, here's an image of bacteria, and here's an image of a tardigrade. One of the weirdest looking things that you might be able to look up online. And a tardigrade is also known as a water bear. Finally, some discussion questions. If you're talking to your friends, if you're talking to your family about what you worked on today for math, why is it that we use these powers of 10 to explain really big and really small numbers? What makes it easier to use the powers of 10? Because that's going to bring us into a deeper understanding of scientific notation. So take some time, maybe write down your own ideas, or if you can, find somebody else to talk to, explain what you're thinking about now in terms of exponents and powers of 10. Pop into our class chat this week with questions or just to say hey, and we will talk to you soon.